see how it goes, right? One sec. Just trying to open some couple of files on this one. All right, so folks, oh sorry, let me put that Donovan in here real quick. Donovan. Yeah, I don't know here. It's up to okay, cool. All right. Yeah, ladies, are ready for your lecture today? Okay, so as I just mentioned, we're going to do some factorization of quadratics today, right? So what I want to do is, again, and I do apologize again for printer not having any ink, right? So what we're going to do is we're going to go through and do all of one type first, and then round back and do the second type. Sorry? It going down? I mean, well, some papers only have one or two things, some only have one, and some have none. So the number of factorization questions is not really fixed per se. So we'll just do whatever is there, right? All right. So just to kind of, before we jump into it, right? So we're talking about factorization. Right. So if I take two numbers, let's say I take 2 and multiply by 3. What's my answer? Oh, sorry, one second. Let's let me in. Right, yeah, my answer is 6. Hey, evening, Liam. How you doing? We now start. We're doing some factorization today, so hopefully you find it interesting. Right. Now, the two numbers that are multiplied are called factors. Now, you can have more than 2 factors, right? You can multiply any number of numbers together. You can do 2 by 3 by 4 by 5, whatever you want to do, right? The item you get is called the product. So when you multiply any number of factors, the answer you get is the product. What we want to be able to do is to take that product and express it in factors, right? As in what numbers multiply together. So, and we're assuming for now, just positive whole numbers. We will relax one of those assumptions going forward, but for now, let's keep it simple. So if I give you 6 and I ask you, what are the possible pairs of factors of 6? I'm asking you, what pairs of numbers, positive, so no negative numbers, so positive, even numbers, that when positive whole numbers, my bad. That when I multiply them will give me 6. So you could always start with 1 and the number itself, because 1 is a factor of all numbers, and every number is a factor of itself, right? So 1 by 6, and of course the other pair that we could see is 2 by 3, right? So these are the factors here. So when you take a product and express it, or you take a number and express it as the product of its factors, that's called factorization, right? What we call factorization, what the Americans call factoring, which I think is a nicer way to put it, factoring, right? So let's take our next number. Give me our next number, next even number. 12, that's a nice number, right? So 12, okay, so give me the first pair of factors that when I multiply, give me 12. Right, 1 by 12. And if you give me a next pair of numbers that when multiply, give me 12. 2 by 6, very good. And Khalifa, your turn. Give me are there any other pairs of whole positive numbers that when multiply give me 12? 3 and 4, very good. Right? So that's what factorization is, right? Now, of course, it goes beyond just knowing your times tables and knowing what by what is equal to this number, whatever the case is, right? Because as we know, we have algebraic terms. So, for example, if we do x multiplied by x, we know we get x squared. So we have algebraic products. If we have terms that are unlike, so if we have an x by a y, we can only write this as xy. So some things would be relatively easy to factorize and some things may not be, right? For example, if I gave you like 24 or 120, we were looking at quite a number of pairs of factors to do there, right? So some terms are a little more involved, right? But if you could break down things into what we call prime factors, that helps. A prime factor is a factor that is a prime number. What's a prime number again? A number that has only two factors, one and itself, right? But that's a whole different line of thought that I just realized I don't want to go down just yet. All right. Anyhow, Emmy, that's correct. 2 and 3, that's correct. Very good. Thanks for responding. Let me just mark William present. Right. Oh shucks, I was supposed to send Javier a PDF of what we're doing. I'm not sure to that right now, so you got it with that. Anyhow. Yeah, cool. So let's go. Right. Now, what we also want to talk about is something called common factors. Right? So when people have things in common, that means that they like the same thing, right? So for example, if so back a few years ago when Game of Thrones was a popular thing, plenty of people used to talk about Game of Thrones. And maybe somebody you don't even know in my head and talking and mention something about the show and it starting it, right? I don't know what show that is right now or what movie that is right now. So when you have things in common, it means you're talking about the same thing. So when we're talking about common factors, we're talking about numbers that have a similar factor. Not a similar, numbers that have the same factor. So for example, if I took 6 and 12 and I compared the list of factors, right? So what factors are the same between 6 and 12? Right? Well, yeah, 1, of course, for sure. Then what else? 6, agreed, and then 2, right? And 3, yeah? Okay, cool. Right? So common factors exist between certain numbers, okay? Now, if I had a situation like, for example, sorry, no. Right? Now, so as we said, factors, right? Sorry, yeah, factors are multiplied together to give us products. The terms we've seen so far have all been what I like to call single terms, right? So what that means is either a number by itself by another number, or an algebraic term by a number or by a next algebraic term. But we have situations where expressions can be factors. What do I mean by that? If I have a 2 and I open a bracket here and put x plus 3 inside, the understood operation between the 2 and the bracket, as we know, is multiply. And using the distributive law, I'd multiply the 2 by the x and get 2x, and 2 by the 3 and get 6, right? So this expression here, what we call a binomial expression, is actually the product of two factors. One is a simple integer, and the other is the previous binomial expression, which I like to call the binomial factor. Bi meaning two, nomial meaning number. So it's a term made up of two numbers or two terms. All right. So when we have to factorize expressions like that, or maybe with even more than two terms, this is where common factors come into play. So what we would do if we had to factorize 2x plus 6 is we would look at each term. We would factor each term one at a time. So if you factor 2x, that's simply 2 multiplied by x. If you were to factor 6, now we have the factors of 6 here, right? What we're looking for is if any of those pairs, 1 by 6 or 2 by 3, has any factor in common with here. So does 6 have any factors in common with 2x? 2, right? So 6 is also, right, 2 multiplied by 3, right? Now you could also express this as 2 by x and 2 by 3, which is basically what we had here. We multiplied the 2 by the x and 2 by the 3, right? And when we could, let me fix that stuff at the back there, right? When we could see that we have a common factor, what we could do, we could literally pull it out and combine what I guess you could call the uncommon factors together. And you get back exactly what was multiplied before, right? So when we multiply out here and expand using distributive law, right? So expand using distributive law, right? And then factorize, right? Each of these is like the opposite of each other. right? When we expanded this, we got that. When we factorized this, we kind of went backwards to that, right? So each of these kind of undoes the other. They are just like two sides of the same coin, right? So when we are factoring expressions, a common factor is necessary, right? Now, most of the stuff you guys will see will have two of them, and it also have powers. Let's do one with powers, right? Let's say we had 2x squared plus 6 x cubed by y, right? So here is a little more involved because now we have indices, right? So if you break it down into its components, right? Who's that? Oh, D'Angelo. Hey, evening, D'Angelo. How are you doing? Good to have you on. We're doing some factorization of quadratics today, right? So yeah, miss too much. We building up to it, right? Okay, cool. Right. So two, if we pull apart 2x squared, we'll get 2 multiplied by what? What do we multiply to get x squared? X by x, right? And what about 6x cubed? Now, 6 we will compare with the 2, right? Now, 2 we know is 2 actually is a prime number. It's the only even prime number. All other even numbers are automatically divisible by 2. That's actually the definition of an even number. It's divisible by 2, perfectly divisible, no remainder, right? So 2 is the only even prime number, which means all other even numbers are multiples or products of 2. So we could pull apart the 6 into 2 by 3. X cubed is how many instances of x multiplied together? 3, right? So we have x by x by x by y. So if we go through here, and let's take off the common factors. So what's common between these two? 2, the x, and the x, right? So if you combine all the common factors together, 2 by x, that'll give us 2x squared. And so 2x squared is the common factor between these two terms here. Now, how do we factorize when we've identified the common factor? Well, when we expanded using distributive law, what operation was used? Multiplication. So if we're going backwards, we need the opposite operation, which is division, right? So we divide each term by the common factor. Now, if you divide 2x squared by itself, any number divided by itself or any term divided by itself will always give us 1. Now, if you divide 6x cubed y by 2x squared, now, technically speaking, we don't actually have to divide based on how we did it here. All we have to do is look at what's left over that is not common. What we have? 3xy. Right? Now, if it was we didn't do it this way and we just kind of eyeball it, hey, 2x squared is a common factor, you would have to divide. It is 6 divided by 2, right? You could even do it like almost like a fraction. 6x cubed y all over 2x squared. And you could decompose the fraction. You could pull it apart. You could put the integers together. You can put the x terms together. And you can put the y. Well, there's no term common with y, so we just use 1. Right? Sorry? Right? Okay, cool. Right? So, of course, 2 into 6 goes 3 times. X cubed divided by x. So now you're using laws of indices. So when you have the same base, x, and you're dividing, what do we do with the powers? We subtract. And 3 minus 2 will give us 1. Right? So that would 1 will give us x to the 1. And then y divided by 1 is just y. And if you look at it, you have 3xy. Same thing. Right? So factorization, right, is the process whereby we take a term or an expression and we try to express it as the product of its factors. Now, not every expression will be able to do that because we will not always necessarily have common factors, especially when you have more than 2 terms. When we have more than 2 terms, like even 3 sometimes, even 2, right? There'll be no common factors. But we have a special case called a quadratic expression. Right? But before I go any further, are you all okay with what I've discussed so far? I'm not asking if you can write a thesis or teach a class in it. You're able to just follow what I was saying. It making sense? Right? Okay, cool. All right, so gentlemen on Google Meet, so D'Angelo, Donovan, and Liam. If you guys are good with what I have so far, give me a quick G. Please and thanks. All right, cool. All right. Do I teach Form 4 is the whole syllabus of PU? Yeah, but by the time I finish in Form 5, yeah, I do rush through syllabus. This is algebra. Yes, it is one aspect of algebra, which is quadratic functions and, well, sorry, quadratic expression and factorization. Okay, right. Now, back on this page, we had an integer 2 by a binomial, x plus 3. What if we had two binomial expressions being multiplied? So x plus 2, then multiplied by x plus 3. Now, what is this? How does this make sense? So before, I mean, there's a very easy way I'll show you to do this, but what I want to do, I want to kind of go down a bit of a rabbit hole, right? A quadratic expression is an expression for the area of a quadrilateral. Do we remember what a quadrilateral is? It's a plane figure with how many sides? 4 sides, a four-sided shape. What are some four-sided shapes? Squares, rectangles, trapezium, parallelogram, rhombus, diamond, kite, etc. Right? There's one called a dart. You'll ever see a dart? Oops, that's not what I wanted to draw, but yeah, okay, cool. Right, so you have 4 sides, right? But we have an internal angle that's bigger than 180. All right. Now this is a square. It has each side is simply x. The area of a square is length by breadth or side by side, right? So what would the area of this square be? It would simply be x multiplied by x, which is equal to x to the power 2 or x squared. That's actually why we call it squared, because we literally find the area of a square when they multiply the same value by itself. It represents the sides of a square, all right? Okay. Now, what if we were to extend horizontally by 2 units? Right, so you have 2 here now, and this is still the same vertical here, x, right? So now the whole shape is a what? The whole shape is a rectangle, right? And the actual width now is actually x plus 2, which kind of matches here, right? But if you want to find the area of this quote-unquote new shape, all we'd have to do is break it up into the original piece and the extension, right? So the extension has dimensions 2 and x. So to find the area of that extra piece, we simply multiply 2 by x, not so? And 2 by x is equal to 2x. So the area of that whole piece now, okay, so the first area was just x squared. The second area, when we added just the horizontal expansion, is the sum of the separate areas, x squared plus 2x. Now, if you consider this by that, which is x by x plus 2, guess what? X by x is x squared, and then x by 2 is 2x. So that is why the distributive law works, because what we are doing is finding the areas of quadrilaterals that are side by side. Sorry. Smiley. Writing off, but that's Smiley. It should be on mute. Evening, Julie. Evening, Julie. How are you doing? Long time no see. How are you? Yeah, I cool. We're doing some basic stuff up here, Ali, some quadratic factorization. So we're just going a little back in time to discuss where it came from. Yes, man. You should check it on the channel. All right, cool. Right. Now, suppose we also extended down 3 units, right? So this side also went down 3 units, and we kind of closed up here. Right? So this is 3 here now, right? So the whole thing would be x plus 3. So what we could do as well is draw in the middle. So now we have how many little sections here? We have 4 sections in total, right? So again, quadrilateral, 4 sections, right? So this horizontal piece matched with this, so it was also x. This horizontal matched with this, so that means it was 2, and this vertical matched with this, so that means this was 3. So if we want to find the area of this whole new quadrilateral now, we have to find this area here and this area here. What is this area here? 3, which will give us what? So 3 by x is simply equal to 3x. And this area here is simply 3 by 2 or 2 by 3, which is 6. And to find the area of the whole thing, we simply add the sum, we'd find the sum of the separate areas. So we'd have x squared plus, so you could do 2x first, you could do, it don't matter, 2x plus the 3x plus the 6. And if we add 2x and 3x, what do we get? 5x. Right, so this here is a quadratic expression. It is the expression of the area of a 4-sided shape that conforms to this particular style or layout or whatever you want to say, right? But what it facilitates is now a shortcut. Imagine every time you had to do this, you had to draw a diagram of this. And imagine if you had to subtract instead of add, right? So remember, when we extended horizontally by 2, the width now could simply be expressed as x plus 2. When you extend it vertically by 3, the expression here is x plus 3. So to find the area of this new quadrilateral, it would simply be this, not so? And based on what we saw, we could multiply each term in the first bracket by each term in the second bracket, right? So let's go. So x by x will give us x squared. We could do x by 3 first, it don't matter, we get 3x. 2 by x will give us 2x, and 2 by 3 will give us 6, which is exactly the same as inside of here, just in a different sequence. But when you add in, does it matter the sequence in which you add the terms? No, 1 plus 2 plus 3, same as 2 plus 3 plus 1, same as 3 plus 1 plus 2. Answer? Right. And of course, when you add 3x and 2x, you get 5x. Right. So now, why am I explaining it this way? Because what are we learning? What are we talking about today? Factorization. This here is the product of 2 binomial expressions or 2 binomial factors. These 2 things here. So if we could multiply these 2 things and get this, we should be able to start with this and work backwards to the product of 2 items, 2 binomial factors. We should be able to, right? The question is, how does that happen? How does it work, right? Now, what might help? Correct, yeah. Right? So one thing that some people do is they take the first term in the first bracket and multiply by the entire second bracket, and then repeat with the second term, 2 by x plus 3. And then x by x is x squared, x by 3 is 3x. 2 by x is 2x, 2 by 3 is 6. Right? So, when we have to factorize a quadratic or factor a quadratic, you have to start with this and literally go backwards here. Right? So the biggest challenge for most people is when you start with x squared plus 5x plus 6, how do I get to this line just before it? How do I, what we call, split the middle term? Your question? Mm-hmm. Correct. Right? So how do we know? So you're correct, right? So if we considered the following, right? Let's say we used algebra, x plus a multiplied by x plus b, right? So as we know, x by x will give us x squared. X by b will give us bx, a by x will give us ax, and a by b is necessarily ab, right? Now, if we have bx and ax, like if you have 3x plus 2x, when you have 3x plus 2x, what does that simplify to? 5x. How we get the 5? We added the 3 and the 2. So here, we could actually simplify this by doing a plus b by x. And of course, a by a, b in the back is a multiplied by b. So the same thing you were saying, we're looking for two numbers. Two numbers must fit two criteria. They must multiply to give us this term, and they must add together to give us the term in the middle. So the numbers we're looking for must multiply to give us 6 and add back to give us 5. So when we're doing that, right, so x squared plus 5x plus 6, what we end up looking for are the factors of 6 that add back, that when we add them together will give us 5. So if we consider 1 by 6 and 2 by 3, which of those pairs of factors will give us 5 when you add them? 2 and 3, right? So now we'll simply re-express the 5x as 2x plus 3x. And now we can do something called factorization by grouping. Instead of trying to factorize 3 terms which clearly have no common factor other than 1, we can now factorize this pair. So between x squared and 2x, what's the common factor? X. And when we divide, what's x squared divided by x? X. And 2x divided by x will give us back 2. And between 3x and 6, I think 3 is the common factor, right? 3x divided by 3 will give us back. And 6 divided by 3 will give us 2. Now, look at this bracket. Is the bracket the same? And in both cases, we are multiplying the bracket by some coefficient. So the bracket is a factor. So the bracket now becomes the common factor. And what happens is the coefficients become the uncommon factor. So we started with this and ended up with this. Right? But we had to split the middle term. And to split the middle term, right, into two numbers. The two numbers we split it into had to add back to give us the middle term, but had to multiply to give us that term there. All right? Right. All right? You want to work circle geometry instead of it? You want to work circle geometry instead of it? Right. You know how you feel about that? Yeah? All right. Add math. Oh, sorry, let me add math people. Well, I see Julie there, so that's all. All right, so D'Angelo, Donovan, Julie, and Liam. If you guys are good with what I have on the screen, just kind of give me a quick Genie chat, please, and thanks. Right? We're going to go through somewhat just like this before we jump into the slightly more difficult ones, right? All right, cool. Oh, yes, I. One sec. Okay, cool. More difficulties. Yeah, yeah, yeah. It gets more difficult, but that's okay. You can handle difficult things. All right. Right. So this item in the pink here is what I like to call the main or primary quadratic identity. Right? An identity. When things are identical, what does that mean? They're the same. Now, normally, like with identical twins, they look the same, right? But there are twins that are non-identical. They call them fraternal twins. But what I mean here is mathematical expressions can be identical. It means that they can mean the same thing, but they can look different. So this expression here is the same or identical to this expression here. It's just that one is the factored form and one is the expanded form, but they mean the same thing. If I put 2 multiplied by 3 on one side of the equation, and the next side I put 6, aren't those two things identical? They mean the same thing. They just look different, right? So this is what we're going to use to help us do some simple factorization, right? So again, the key is the two numbers must add back to give us the same middle term, but multiply to give us term at the end, right? So let's just do a quick few, right? So let's say I have x squared plus 7x plus 10, right? Let's say I have x squared plus 6x plus 8. Let's say I have x squared plus 9x plus 20, right? Now you don't have to go through this whole process here, right? All I want you to do, I want you to look at the numbers, right? We're trying to figure out what two numbers, when I add them together, will give me 7. That will also give me 10 when I multiply. So it's easy to think of the factors of 10 than to think of the addends of 7, because 7 could have many. Could have 1 plus 6, 2 plus 5, 3 plus 4, 0 plus 7, right? And if you go negative, it's a whole bagger, right? So let's focus on that one. So what are the factors of 10? What pairs of numbers will multiply give me 10? 1 by 10 and 2 by 5. Do either of those pairs add back to 7? Which one? 2 and 5, right? So all you have to do now, so we've identified 2 and 5 and 2 by 5. So all we have to do here is put x plus 2 by x plus 5. All right? What about x squared plus 6x plus 8, right? Here's 8 done. So we're looking for two numbers that when you add it together give us back 6. And when they multiplied, give us back 8. So again, go more to the factors of 8. What are your factors of 8? Quadratic. That's correct, yeah. What's that? 1 by 8. Anything else? And 2 by 4. What was 1 plus 8? 1 is 9, so that's not 6. What about 2 and 4? That's 6, right? So 2 plus 4 is 6, and 2 by 4 is 8. So you can factorize very simply. X plus 2 by x plus 4. Yeah. Right. What about 9 and 20? Is there a pair of numbers that when I add it, give me 9, and when I multiply, give me 20? What are the factors of 20? 1 by 20, 2 by 10, and 4 by 5. 1 plus 20 is 21, that's not 9. 2 and 10 is 12, that's not 9. 4 and 5, however, is 9. So all you have to do is put x plus 4, x plus 5. And it doesn't matter, you can put the x plus 5 in front of the x plus 4, it doesn't matter because you're multiplying those two things. And as we know, multiplication is commutative. It doesn't matter. A by B is the same as B by A. 2 by 3 and 3 by 2 are both equal to 6. All right. All right. Now, as we know, things don't always stay as simple as this. Quite often we have a negative term or two in the mix, right? So what we want to do now is we want to expand our vision to include those things. Hey JD, how you doing? So let's do a couple examples, right? So let's do number 4 here. Right? So let's say we have x squared minus, hold on, minus 7x plus 12. Now check this, right? We're looking for two numbers, and when they multiply, add them together, give us minus 7. But when they multiply them together, give us positive 12. So how does this work? How can we add two numbers and get negative and multiply and get positive? If both of them are negative, right? If both numbers are negative, if you add two negative numbers, you get back a negative. If you multiply two negative numbers, however, you get a positive number. So whenever you have a positive product but a negative sum, the numbers have to have, well, I'm sorry, the numbers will both be negative factors, right? Okay, so before you worry about the signs, worry about the factors. What are your factors of 12? 1 by 12, 2 by 6, and 3 by 4. Okay. And now we know that the factors have to have the same sign. And which of these pairs of numbers, when added together, will give us minus 7, minus 3, minus 4? So now when you factor here, you'll end up with x minus 3 by x minus 4. Alyssa, yes, that's correct. Yes, positive if you do a minus by minus. Correct. Good job, guys. My people have any comments to make? Right. Yeah. All right. Right. Okay. So let's do. Okay. Let's do x squared minus 8x plus 15. Right. So what am I? Was my pair of numbers, and when I add them together, give me minus 8. And when I multiply, give me positive 15. So again, if I'm multiplying two numbers, they're getting a positive. It means that the numbers, the factors have to have the same sign. They're either both positive or both negative. And to know what sign it is, I have to look at my middle term. So 15. Think about the factors of 15. 1 by 15 and 3 by 5. And because we know the signs are the same and they're negative, we put minus signs. Do either of these pairs of numbers add back to give us minus 8? Correct. Minus 3 plus minus 5. And then minus 3 by minus 5 is minus, it's positive 15, sorry. So your factor here, sorry, your solution here. Right. Okay, in class, ladies, any questions or are we okay? You take a little nap. You missed some stuff or you okay? You're okay. All right. All right, Google Meet. Do the drill. Donovan, they are Julian and Julie. I give them a quick G. If you're good with that. Cool. Sorry. Minus 5 and minus 3. Yeah, that's correct. See that. Okay. Now, what about if we were just to kind of mix up those signs? What do I mean by that? So let's try the next one. Right? Let's say we have x squared. Now, you'll notice here that this constant in the back is actually negative this time. The term in the middle is positive. So what's going to happen here is we're still looking for factors of 14, minus 14. And when you add them together, it'll give us back positive 5. Now, initially, again, like I said, don't worry with the signs just yet. Just focus on the factors. What are your factors of 14? 1 and 14 and 2 by 7. Now, what about minus 14? To get a negative product, to get a negative number when you multiply two numbers, what does that tell us about the signs of those factors? One is positive and one is negative. But how do we know which one? That's where this comes in. If when we combine a negative term and a positive term by addition, we get back a positive term, it means the positive term had the larger, it was the larger of the two, right? So like here, the 14 and 7 will be positive and the 1 and the 2 will be negative, right? So let's check it out. So if we put minus 2 plus 7, we will get back 5. And of course, minus 2 by 7 is minus 14. So when you express it as a factor in factored form, right? So when the term to the end is negative, the factors have different signs. And whatever sign the middle term has, the larger factor is the same sign. Right? Let's switch it. Let's say, sorry. Let's say we had x squared minus 4x minus 21. So again, we're looking for two numbers, and when you add them together, it'll give us a minus now. And when you multiply them together, it'll also give us a minus. Right? So again, we're looking now for the factors of 21. Sorry. So the factors 21 are 1 by 21 and 3 by 7, but it's actually minus 21. So we know in each of these pairs, one factor will be positive and one will be negative. How do we know which one? Whatever sign that has, the larger factor is the same sign. So which of these pairs, when you put them together, add them together, give us minus 4? The 3 and the minus 7. Ukibua. Yeah, that's correct. Very good. Ukibuki. Interesting name. Right. So from here now, all we have to do when you're factoring is it'll give us x plus 3 and x minus 7. Right? Now, again, what I showed you here was a bit of a shortcut to factorize relatively simple quadratic expressions, right? This here is kind of what I prefer to see, but as far as I'm concerned, it's a lot of work for a little bit of marks. 3 and minus. Yeah, that's correct. 3 minus. Thanks for sharing that, Cara. Appreciate it. Okay. So what we're gonna do, we're gonna take a little browse. Okay, so there won't be many questions like this though. One sec. Yeah, what we see in here is most of them actually have a coefficient for the squared term. This one we could factor. Okay, so we have two that we could do. We could do Jan 2015 and we could do Jan 2025. So again, unfortunately, I can't print out anything because my ink kind of done. Right? So I want you all to do this one for me here. We'll come back to this. Don't do this yet. Right? We'll come back to that as a special case. It's actually pretty easy. Once you see the trick, you can get them out all the time. Yeah. All right, ready? Okay. So let's start there. So if we consider x squared minus 5x plus 4. Right, so again, we want to factorize this, express it as in this form, right? So we know we need x in the front. But we need to know, well, what did we get in the middle there with the numbers? Now, what we saw just now, the two numbers we're looking for will have to multiply to give us -4 and add back to give us +4 and add back to give us -5. So again, we said what we do is we look for the factors of the constant, the term independent of x. So 4, what are your factors of 4? 1 and 4 and 2 by 2. Now, because it's a positive product that comes from two factors, we know both factors have to have the same sign. They're either both going to be positive or both going to be negative. How do we tell in this particular case? Whatever sign that has, the factors will have. Because when you add them together to get back a negative term, they both have to be negative in this case. Because when you multiply them, you have to get a positive. So which of these pairs of factors will add back to give us -5? -1 and -4. Right? Now, again, like I said, this is a bit of a shortcut. What they would prefer you to do, and I'll show you just for illustration, but I still think you should be able to get away with what I just did. Right? So again, once you figure out what to split it into, you can do x squared minus 1x minus 4x plus 4, and then factorize by grouping. So between x squared and x, what we have is the common factor, x. When we divide, x squared divided by x is x, and then x divided by x is 1, well, -1 in this case. Now here you have a -4 and a +4. We'll use -4 as the common factor, because when you divide a minus by a minus, what do we get? A plus. And when you divide a plus by a minus, what do we get? A minus. And are these two brackets now the same? Right. If they're the same, we could proceed. We could pull the bracket now as the common factor and put the coefficients together as the uncommon factor. Right, so they prefer you do this, but again, like I said, I think you should be able to get away with that. Right. Cool keyboard. Right. So you didn't say quadratic form. You could do that. You could do that, yeah. But I don't think you should have to. Oh, cool. Sorry. Square. The answer 4, right? Stuff of really there. No, that's the intercept. All right, cool. Right, good. Well, school, you clearly know what you're doing. You leave my class. I can go and take a sleep. I'm tired. My options like 4:15. And this is my 4th class for the day. All right. Okay, ladies, are we okay with that? All right, Google Meet. Are we okay with that one? Give me a quick G. Donovan, D'Angelo, Liam, and Julie. Yeah? All right, cool. Okay. Right, so in Jan 2025, we have this one here. Right, so do that one for me. Sorry, I'm not doing that. Right, right. So I saw a picture with you and Kerwin Springer. You seem really tall. How tall are you? Or the signs? But yeah, the signs. Yeah, correct. Correct. Yeah, sure.
Oh, sorry, I wasn't stuttering. So, and that means. Sorry. So this angle right here, they found it. Can you say that including
What was that? Yeah. Right. Just add maths or normal maths. Normal maths, but this also is very much heavily featured in maths as well. Right. Yep. All right. Let me check this one real quick, and then we'll go from there. Right. So you want to split the middle two. But we're looking for the factors of 35. Right. So forget minus 35 first. What about regular 35? What are your factors? 1 by 35 and then 5 by 7. Now, because the product is negative, we know the factors have to have different signs. One positive, one negative. How do we know which one has which sign? Whatever sign that has, the larger factor has the same sign, which means by default, the smaller factor has the opposite sign. Right. Which of these pairs will give us back positive 2? Minus 5 and the 7, right? So again, to me, you should be able to just jump to the answer. X minus 5 and x plus 7, right? Again, the slightly longer way you could do it is like this, right? So you could put x squared minus 5x. So you're splitting 2x into minus 5x plus 7x, right? And you factor in each pair of terms by grouping, right? So between x squared and 5x, the common factor is x. And when we divide, what's x squared divided by x? X. Minus 5x divided by x is minus 5. Between 7x and 30, minus 35, you can put 7 as the common factor. 7x divided by 7 will give us x. And minus 35 divided by 7, a minus divided by a minus is a plus. Sorry, by a minus, right? And then just plain old 5. And now, are the brackets the same? Yes. So what we do is we pull the bracket as the common factor. It don't matter. X plus 7 by x minus 5. So remember, it's multiplication. So whether you do 2 by 3 or 3 by 2, no matter. Minus 5 by 7 and 7 by minus 5 is the same thing. All right? All right, cool. All right, sorry. I think I need to put on my glasses, boy. I have some trouble seeing. There's like 3 feet in front of me. That's not much better. Yeah, Pookie. Yeah, that's correct. Okay, ladies, are we okay with that? All right, Google Meet, Nigel, D'Angelo, Donovan, Julie, and Liam is going to have a quick G if you're good with that. Thank you. Okay. All right, so now we're going to up the game a little bit. We're going to go back and we have to look at all of those questions where we have a coefficient of x squared other than 1. Right? We have one simple change to make to the process, one little tweak, and that's it, right? So we answered the UTC. Yeah, I've seen it for the fraction. Yeah, I see it. Yeah. Cookie, yeah. All right. So what I'll do is I'll use this one here as an example, right? So this is the May 2015 paper, right? If we have two x squared minus 5x plus 3, and you want to factorize that. We have one little tweak to make. So normally, we just ask for the factors of that. But what we have to do now is actually multiply the coefficient of the x squared term by the constant, right? So what we are looking for actually are the factors of 2 by 3, which is equal to 6. So what are the factors of 6? 1 by 6, and of course, well, 2 by 3. But we're looking for the pair that when we add it together will give us back minus 5, right? Now, we said earlier, when you have a positive product, it means the sign, the factors have the same sign, either both positive or both negative. And how to know which to use is to look at the sign in the middle term. Whatever sign that has, in this case, the factors will have the same sign. So which of these pairs will give us minus 5 when we add them together? Minus 2 and minus 3, that's correct. So we could split minus 2x in the middle into minus 5x into minus 2x minus 3x. And then factorize by grouping. 2x squared and 2x, the common factor is clearly 2x. When we divide, we get x minus 1. Here, you can pull minus 3 as the common factor. When you divide, you get x minus 1. Now, x minus 1 becomes a common factor, and you have 2x minus 3, right? And again, you can put 2x minus 3 in the front of x minus 1. It matters not because you are multiplying them. And when you're multiplying, it's commutative, right? Right, so this is the example here. So again, the one tweak we make is you have to multiply the coefficient of x squared by the constant, and that number, that power minus any bracket. Oh, that's not. Line 1, line 2, line 3, line 4. Line 3, right. So what I'm doing is for each pair of terms, I wanna factorize each pair, right? So between 2x squared and 2x, clearly, well, 2 is the common factor between the numbers, and between x squared and x is the common factor. What I do now is I divide 2x squared divided by 2x. So 2 goes into 2 one time. X squared divided by x will go x times. And I want to divide minus 2x by positive 2x. So a minus divided by a plus is a minus. And 2x divided by 2x is 1. Now, when behind here, right, I have minus 3x and positive 3. So the kind of trick you could apply is whatever sign is here, you use that, right? And then you use the common factor. So between 3x and 3 is the common factor. Now when we divide, a negative divided by a negative is a positive. And 3x divided by 3 will just give me back x. And then a positive divided by a negative will give me a negative. And of course, 3 divided by minus 3 will just give us minus 1. Yeah? Okay. As in how to find a common factor? Yeah. Right, because the numbers you're looking for are not the factors of this. What? Hold on, this now. Sorry. Right. Right. So what happens, Kiona, is in the previous ones, we just looked at whatever value this was and found the factors, right? Now what we're doing is we're multiplying this term by that term, right? And that is what we're looking for the factors now. That's it. Yeah. Technically, we were always doing it. It's just that in the previous ones, the number in front of here, where no number is explicit, what number is understood? 1. And 1 by anything will give us back the same number, right? Okay. All right. Ladies, we okay with that? Any questions, problems, anything? All right, Google Meet. So Deanna, Donovan, Juliana, and Liam, if you guys are good with the examples, give me a quick G. I know I just asked you, but wait, hold on, sorry. You're giving already. Okay, cool, thanks. Okay, cool. Right. Okay, so try this one for me now. Try this item here. 3y squared plus 2y. So this is May 2016, by the way. All right, so 3y squared plus 2y minus 8. So remember, you're multiplying those two terms. So you're looking for the factors of 3 by, right? What did,
I was right so far. This line is parallel. Yeah. So this angle and this angle. What's your mind on the other side?
come on. Okay. All right. The cut. Okay. Oh, yes, yes, for sure. Okay. Okay, cool. Thank you. Yeah.
Yeah.
Right. Okay. So still see some pens right here, so we'll give them a minute. Oh, who's that? Something there. I don't know what it was. No, the three stays attached. Yeah. All right. So, like we said, start with just factors of 24, right? So, what are your pairs of numbers that will multiply give us 24? 1 by 24, 2 by 12, 3 by 8, and then 4 by 6. Now, because we have a negative product, we know one factor will be positive, one will be negative. How do we know which one is which? Whatever sign that has, the larger factor has the same sign, which means the smaller factor has the opposite sign. Right, now which of these pairs, when you add or subtract, will give us 2? Minus 4 and the 6, very good. So that's how we're going to split. Now check this, right? It doesn't matter if you put the minus 4 in front or behind. It would actually be easier for you to do this if you did this. 3y squared plus 6y minus 4y minus 8. Because, all right, what I'll do, let me factor it this way and I'll go back and factor so you see how to do it. All right? Because remember, minus 4 plus 6 is the same as 6 minus 4. Because that's what 2 is. 2 is 6 minus 4, not so? Right? So between 3y squared and 6y, we could say, well, 3y is a common factor. When we divide, 3 into 3 goes once, and y squared divided by y is just y. And then 6y divided by 3y will give us back 2. Now, these two terms are negative, so we'll pull back our negative 4. And when we divide, minus 4y divided by minus 4 is positive y. Minus 8 divided by minus 4 is positive 2. We see now these two binomials are the same. So we have y plus 2 as a common factor, and then the coefficients are simply collected in the bracket. Common factor to the front, the uncommon factor to the back. Right? And like I said, what I promised I would do is I would show you the other way as well. If instead we put the minus 4 in the front and the 2 to the back, sorry, the 6 to the back. So check it. If we did it this way, between 3y squared and minus 4y, y is the only common factor. All right? When we divide, it is going to get 3y minus 4. Same thing here. Between 6y and 8, only 2 is the common factor. And when you divide, you're again going to get 3y minus 4. But we do get 3y minus 4 both times. Was that sorry? Yeah. That's what you're doing, right? So you have to look at the... Yeah. I don't know. Thank you, Cupcakes. Aaron, 75 is a good mark. It's a pretty good mark. It's better than 670 for sure. But yeah, I would say aim for that for sure. If you could aim higher, aim higher. All right, D'Angelo, Donovan, Julian, Let's give me a quick GD chat if you're good with that, please and thanks. All right. Okay, ladies, any questions on this particular item here? You okay with it? You sure? All right. All right. What topics do paper 3 usually consist of? I don't know. I really haven't inspected many math paper 3s. The few I've seen some factorization, some plain geometry like measurement, area, that kind of stuff. But I know I have some paper 3s, but I haven't gone through them. How many papers are there? There are 3 papers. Paper 1 is multiple choice. Paper 2 is long paper. Paper 3, you have 2 items. I either have paper 031, which is the SBA, or 032, which is the written paper, the substitute for the SBA. Go through them. Go through what? Go through them. Oh, that is if I had time to do that way. All right, so we're going again. Right, so this one here is yours now. 2t squared minus 3t minus 2. Go ahead. Yeah, Aaron, there's no way to know. The examination body has never released the grade bands to inform us what percentages were what grades in different years. It's not a fixed percentage. Right? It depends on how everybody that year does. Yeah, unfortunately, I don't know. Complicated? Well, I mean, life gets complicated. I know how to deal with it. Ali, what you finding complicated? Talk to me. Mr. Grass, how is circle theorem? Funny part, Mr. Grass is actually the other class on the other side of the room is doing circle theorem right now. But you know, you can check my YouTube channel, check the same channel and see if you see circle geometry. You can search across the channels. Use search for circle geometry or circle theorem. Mr. Grass. Yeah. That's correct. Positive 1 and minus 4. What time was that? Normally 6:30. So I aim for 6:30, but 6:45 I normally start. So I'll lose 15 minutes. Yeah. Sorry, Nadine. Study in Arabic. Have an important ministry. Okay, cool. How do you solve 3x squared minus 9? Actually, I can show you that, Nadine. Right. So what you do first of all, you factor out the 3. You get x squared minus 3. That's about it. You can't do much more than that. I mean, the only other thing I could say is if you have to use surds. Well, I don't know if that's on your syllabus. XD. Idle sounds kind of Japanese. Yeah. Okay, cool. Let's take a look at the blue, right? So factor. So what are we multiplying by what? 2 by minus 2. So 2 by minus 2 is minus 4, right? So you want the factors of minus. Well, we only have 2 sets of factors, 1 by 4 and then 2 by 2. Because it's a negative product, we know one factor in each pair has to be negative and one has to be positive. How do we know which one is which? Well, whatever sign the middle term has, the larger factor has that same sign. Easy, right? So which of these pairs of factors will give us minus 3 when you add them together? 1 and minus 4. So you split it. So you're going to get 2t squared. So you can put minus 4t plus 1 or plus t minus 4t, don't matter, right? So let's do that. Let's put plus 1t minus 4t. Right, so you factor the first pair of terms. Between 2t squared and t is the common factor. And when we divide, we get 2t plus 1. Now here you have 2 negative terms, so it stands to reason you have a negative common factor, which would be 2. A negative divided by a negative is a positive, and 4t divided by 2 will give us 2t. Minus 2 divided by itself will just give us back 1. And now we could see the brackets are common, so we're going to get 2t plus 1, and then t minus 2. Minus 1. Did I say minus 1? Okay, that's my mistake. Oh. Right. Iraqi. Wow. You go on, yeah, man. Yeah, man, later. All right. Right. So 4 can't be the common factor because if you did 4t divided by 4, yeah, you get t. But 2 divided by 4 is a half. Like here, you can't pull out 2 as a common factor because 1 divided by 2 is a half. So technically speaking, you could, if you did the division correctly, you had the correct answer, right? So like here, between 2t and 1t. So between 2 and 1, the largest common factor is actually 1. Between t squared and t, t is common factor. Physics guy? Okay. Yeah. Between 4t and 2. So between 4 and 2, 2 is actually the highest common factor. So you can factor with 2, right? So usually what the kind of rule is it has to be the smaller number, the smaller power if it's the algebra, right? So that's this one. Yeah. So when you pull out, yeah. So like here, you pull out 2t squared plus t. T is the common factor. It's 1t.
Oh, so I put this here. Okay.
Like I said, if you actually did the division correctly, what it would look like is this. You get t minus a half. And here, if you did minus 4, you also get t minus a half. So it will be the same. So you actually get t minus a half or 2t plus 4. Right? Which is not fully factored because you could factor out 2 here. And when you factor out 2, you can multiply that by the bracket and you get 2t minus 1. So, but it's just not complete. Right? Okay. All right, guys. That makes sense. All right, cool. Oh, Nadine, some interesting stuff going. Circles theorem is challenging. Yes, it is correct. That's correct. It is. It is very rewarding once you get a handle. Okay, guys, going again. Nothing here. Oh, sorry. Yes, we could probably finish off most of the May papers for now. We leave January for Monday, right? And on Monday we'll do difference of 2 squares and all the other little stray ones and the word problem. Next week. So the date. So next week. Next week we have regular class up until the last day, up until Wednesday. The following week, so Tuesday, Wednesday, Thursday, classwork. Pretty moody, man. How you doing? Yeah, Nadine, if you have to solve it and it's equal to 0, then I think those values would be correct, yeah. Yeah, plus or minus root 3, that's correct. Okay, cool. All right, go ahead. All right, cool. So that's 2018, May didn't have anything. Right, so this one, May 2022. So they wanted to factorize and solve. So what I want you to do is factorize, and then I'll show you how to solve. If you know what to do, of course, by all means, go ahead. Do something with this hair. This looks kind of dumb. I don't know how to do. I've had this for 5 years now. I still need to do a manual. Do part 1, and I'll show you do part 2. How far back do you want to go?
How far back do you want to go? As whatever is the hardest. No!
We can't go back that far because it has some stuff not in the syllabus, like geometry. My paper?
Yeah.
I was upstairs, you know?
No way.
It have 1 or 2 things not in the syllabus, like with geometry and
What is that?
basically it's if you're traveling along lines of longitude, it's just the distance, and because it's on a sphere, it's an arc. What was that? Sorry. CXE. It had no C-second cape. Yeah. Yeah. Right, equal to 0. So same thing will be different. Correct. Yes, you just factored. Yes, Nadine. Very good. Cambridge CXC came on in the 70s, yeah? So prior to that was Cambridge, yeah. GCE. I think even my mom did like stuff like GCE, and she would have been in school around those 60s. My mom was born 55, so yeah, and oh no, 76 should have been 21. My mom is like 70, so. All right, yeah, guys. I'm just gonna write it out. I'm not gonna do it yet. All right, so we're gonna start with 5x squared minus 9x plus 4. So looking for the factors of what? Factors of 5 by 4. 20. That wouldn't work. Nah, wouldn't work. That's correct, yeah. So they give them the first step first, and then factor it first, and then solve it. So they used to ask them to solve it in one go, but they decided to kind of break it up in pieces to scaffold them through. Right. So you have a positive product, which means the factor have the same sign, either both positive or both negative. This tells us they're going to both be negative, right? So you have the right one because you need a 9, but it'll be minus 5 and minus 4. Because if you remember, when you split the middle term, if you add these back or subtract or whatever, you have to get back that. If you do minus 5 plus 4, you have 5 negatives and 4 positives. Cancel out and give it back 1 negative. So it's going to be minus 5 and minus 4. Like here, 5x squared and 5x has this as the common. That's correct. 5x squared divided by 5 is x. But 5x divided by itself is actually 1. Because if you have x by x minus x, you get 0. And then the whole thing falls apart. Right? 4x. So if you pull out 4, 4x divided by 4 is x, but 4 divided by 4 is 1. Right? And if you notice, you have a minus here and a plus here. So these are not the same. So if these are not the same, you cannot go to the next line because remember, you can only factorize if you have a common factor. Right? But all right, we get in there. We get in there. We zoom. Right. Caribbean. Yeah, hold on, sorry. Hi, good evening. Uh-huh. No problem, what's up? Oh, Lord. Yeah, no, I just asked him. Those I say you don't have keys for home. No, you don't have keys. So what to do? No, she must have come into months after January. Nyla is here, yes. Nyla, would it be possible for Josiah to land by you for a 5 while his mom picks him up? Yeah, Nyla says it's fine. Josiah, are you fine with that? Oh, okay, he says he will go by Jaden. Yeah. And Jaden gets picked up. Rivero, okay, God. From curiosity. Josiah, your mom wants to know where he lives. Oh no, sorry. He said other Jaden, his Jaden. White? Yeah, yeah. Oh, you're getting there.
From Jaden.
You're getting a drop from the other Jaden here. Okay, cool. All right, no problem. Yeah, no problem. All right, bye. Oh, okay. All right. Yeah. So 5. So yeah, 1 by 20, 2 by 10, and 4 by 5. Right now, it's a positive product, so the factors have to have the same sign. How do we know what sign that is? The middle term dictates that. Which of these pairs gives us -9 when you add them together? -4 and -5. Right. Right. So now we split the middle term. So you could put the -5 in the front and the -4 at the back to make the factorization simpler. So between 5x squared and 5x, 5x is the common factor. And when you divide, you're going to get x minus 1. Here, we could pull -4 as the common factor. So when we divide, we will get x minus 1 again, because a minus divided by a minus is a plus, and a plus divided by a minus is a minus. So now, because the brackets are the same, we can factor again. All right. Sorry, I don't know the name. I've seen -5, -4. You have it twice, but I don't have a name. I don't know what symbol that is, so I can't even give you credit for it. Yeah. So if you give me a name, I'll try and remember the name. All right, Google Meet. If you guys good with that, give me a quick Genie chat, please and thanks. All right, cool. Ladies, you okay with that factorization? Any questions? Anybody? Anything? All right. Okay, now they give us this statement here, which is the same thing but put equal to 0. So if 5x squared minus 9x plus 4 is equal to 0, and when we factorize this, we got that, it stands to reason, therefore, that x minus 1 by 5x minus 4 is equal to 0. The understood operation between the two brackets is what? Multiply. So this gives us an interesting statement here. This statement says that when we multiply these two things, we get 0 as the answer. So think about that. If you multiply any number of things that get 0, there's only one way to get 0 when you multiply. You have to multiply by 0. So what it means is that one of these things has to be 0. So because x is variable, we have to consider each one of them equal to 0 in a separate case. So either x minus 1 is 0 or 5x minus 4 is 0. So if x minus 1 is 0, what number, when you subtract 1 from it, gives us back 0? 1, right? So x had to be equal to 1. Across here, what we would do, you'd move across the 4 first by adding it to both sides, and then we would divide by 5 to solve for x. You should. Yeah. A while ago. Yes, 4/5 and 1. That's correct, Lee. Very good. Yeah, that's correct. Cool. Right. Fiona, you okay with that statement there? Right. Hanifa, what about you? You okay with that? You talk to me. I see your thumbs working overtime there. All right. Sorry. All right. We have time for a couple more real quick ones. Ready? Oh, yeah. Ready? Yeah. Right. Try this one. Me? Okay. You know, we did it in January, yeah? We did it in January. So you can check the replay. What's that? Right, but the replay is available. If you need it, let me know. I can send it to you. So yeah, what to do? Send my WhatsApp and I can send you links there. Your bomb?
Yeah.
No. What's that?
Oh, like 60%.
Your battery swell.
Yeah.
What?
But I'm convinced it's gonna explode.
Well, if you leave it long overcharge, it could.
But I kind of leave it to charge overnight because
What iPhone is it?
11 Pro, but I've changed the battery like 3 times because I changed the battery once. The battery didn't work. Changed it again.
Maybe you
That
should
one
get a
didn't
new
work.
phone. After C6.
Yeah, that's a problem. The problem is when I'm working in Canada. I'll say
Yeah. You ought to go to the mid 2000s. I would say. If not, check. You can check Jan 2019. The recent ones, I mean, they did them already, so I wouldn't get them anything recent. Yeah. If I didn't send them to you, let me know. I'll send them.
No, I have back till 2015, I think.
Mid 2000, so like 2006, 2007.
Yeah, okay, I could use
All right. Let me know. I could send that to you, right? All right. So what are your factors of 24? You have 1 by 24, 2 by 12, 3 by 8, 4 by 6. Okay. Now we have a negative product. What does that mean? It means the factors have to have different signs. One positive, one negative. How do we know which one is which? This tells us the sign of the larger factor, which means the smaller factor has to have the opposite sign. And which of these pairs of numbers, when we add or subtract, will give us positive 5? -3 and the positive 8. Very good. So we could split that now. So what we could do, if you want, you could put the 8 in the front and the -3 to the back. And then you could factor by grouping. So between 2x squared and 8x, 2x is clearly the common factor. When we divide, you get x plus 4. The two terms are negative, so you can pull out a negative common factor. When we divide, again, you're going to get x plus 4. Because you're dividing each term by the common factor. And now x plus 4 by x plus, x plus 4 is the common factor. Now, I'm going to add one extra thing, right? So just to kind of give a little practice what we just did. So if 2x squared plus 5x minus 12 equal to 0, right? So if this is equal to 0, solve for x. So do now. We have like 5 minutes. We just did that one in the previous question. If you put that equal to 0, it means that this equal to 0, and you can solve for that. Right. What if a question can't be factored? What do you do? Okay. So if you can't factor it, yeah, you can use the quadratic equation to solve for x. Hold on. You can see it from Iraq. What time is it by you? It's 8:30 here. So you 12 hours ahead. So 8:30 in the morning? like Japan is like 14 hours ahead. Australia is like 15. So Iraq is a little closer. It's not as far east as those places. So a couple of like 4 hours behind them. Abby. Abby boy. All right, Abby. Let me see. 4 minus 4. Yeah, so all right, cool. Right. So if that is equal to 0, then x plus 4 by 2x minus 3 is 0. So again, we have a statement saying here that the product of two factors is 0. So when you multiply these two things, you get 0. The only way to get 0 when you multiply, the only condition is that one of your factors has to be 0. So we consider each one in turn because x is variable. Its value can vary or change. So either x plus 4 is 0 or 2x minus 3 is 0. In which case, if x plus 4 is 0, you'll subtract 4 from both sides of the equation to solve for x. And if 2x minus 3 is 0, first of all, you'll add 3 to both sides, and then we'll divide by 2. Right, minus 4 and 3 over 2. Very good. You have a name. Right. We get what? Which negative? Right here? Right. Because if x plus 4 is 0, to solve for x, you have to carry over the 4. If you're adding the 4 on this side, you have to subtract it to carry it over. All right, okay. So folks, we're going to put a pin in there for today. Now, just in case you forget, sorry, give me 1 second. Let me just pull up the schedule for next week, right? Now, the schedule for next week is as per usual, right? If I would like to be, but unfortunately, no. I don't have cash on me today. So tomorrow, when you, well, hopefully, all right, okay, cool. Yeah. All right, no problem. Cool. Yeah. Right. Yeah, guys. So just a reminder, we have class as per usual next week, Monday and Wednesday. But as Wednesday is April 30th. After that, we officially in exam season, right? As you could see, we have POA binging the rest of the week. If you want to have maths in the 4 to 6 session, let me know, right? But after POA, we binge. I can even put POA, maths at 1 o'clock here if all I want, right? Because I know not everybody here doing POA. No, I know some of y'all doing EDPM, some of y'all doing French, some doing TD, some might be doing HSB. If you have to study for those things, you do your thing. Come for what you could come for, all right? But yeah, and then after that, we have the multiple choice down at the end of June here. Well, sorry, the start of June. And we'll try to put in some multiple choice sessions before. I could kick out the Form 4s because they have more time before the exam. That's not a problem, right? But yeah, so guys, we're on the final approach. Not long again now. Don't panic. Set your plan, do your work, and trust the process. All right, Google Meet. I'll go on there. I'll see you guys hopefully next week. Bye. All right. YouTube, holiday, 14 viewers, boy. All right, so guys, that's the plan. So nothing for the rest of the week. Might see some shorts popping up, some stuff on Instagram. Right, we'll see what we can do. But my YouTube channel has quite a bit of stuff. I've been streaming my lives public for the last few months, so there's a wealth of stuff there that you're going to make use of.